Have you ever looked at a super sleek modern skyscraper, or maybe even a really vibrant solar panel, and just wondered, how did they get that perfect finish? You know, we're surrounded by all this tech that's not just functional, but it's genuinely beautiful, and well, behind that beauty is some pretty incredible science. So let's dive into that hidden world, where we're literally painting with atoms to build a more sustainable and, honestly, a more stunning future. Okay, so first stop for us is a conflict that architects and engineers have been wrestling with for years. It's this clash between how things look and how we build them sustainably. It really just boils down to this one big question. I mean, for the longest time, going green meant you had to compromise on design. Think about it. Those early solar panels? Yeah, they weren't exactly winning any design awards. So the question was, do we really have to pick one? A green future or a good-looking one? And you can really see the split here. On one side, you've got pure function. Those bulky, clunky solar panels designed for one thing and one thing only, capturing energy. But then, on the other side, you've got form, the clean lines, the seamless surfaces that we expect from modern architecture. For a long, long time, these two things just seemed totally incompatible. There was this huge gap between what was efficient and what was actually elegant. But what if I told you there's a technology that can bridge that gap? It's kind of the hero of our story today. It's a process that lets us have both incredible function and stunning form. So let's get into how it works. It's called RF magnetron sputtering. I know it sounds incredibly complicated, right? But the concept behind it is actually pretty elegant. The best way to think about it is like spray painting, but instead of tiny droplets of paint, you're using individual atoms. You're literally building a new surface one atomic layer at a time, with a kind of precision that's just hard to even imagine. So how does this atomic spray painting actually happen? Well, you start with a vacuum chamber to get all the other air out, then you add a harmless gas, something like argon. After that, you hit a target material, let's say it's a piece of metal, with a bunch of energy. This literally knocks atoms off the target. Those atoms then fly across the chamber and land on a surface, like a piece of glass, forming this ultra-thin, perfectly even film. It's manufacturing, but on a nanoscale. And the real key here, like this says, is control. This is not just slapping on a coat of paint. We're talking about a precisely engineered architecture at the atomic level. You can control the thickness down to a single atom, you can mix different materials, and you can build up these really complex layers. This level of control is the superpower that lets us create brand new materials with some absolutely incredible properties. So what can we do with this amazing superpower? Well, let's start with our first big application, giving solar panels a much-needed makeover and, even better, integrating them right into our buildings. This whole idea is called Building-Integrated Photovoltaics, or BIPV for short. And the goal is simple but ambitious. Get rid of those ugly bolted-on panels. Instead, make the building's own facade, its windows, maybe even its roof, part of the energy-generating system. We could turn entire buildings into power plants that just blend in. But wait, how do you make a solar panel a different color without killing its efficiency? I mean, you could try using regular pigments or dyes, right? But as you can see here, that's a pretty bad idea. They fade in the sun, they degrade in bad weather. Sputtered films, though, they're incredibly durable, the color is totally stable, and they're designed from the ground up to have a minimal impact on how much energy is produced. Okay, but this method of creating color does come with its own unique challenge. The color isn't from a pigment, it's created by light waves interfering with each other. And sometimes this can cause this shimmery, iridescent effect where the color actually changes depending on where you're standing. Now, that might be cool for a car, but it's not exactly ideal for a building facade that needs to look uniform. The solution to this problem is something called the Kromatix concept. Using sputtering, scientists can create these really complex stacks of different materials, things like titanium dioxide and silicon dioxide. By precisely controlling the thickness of these alternating layers, they can basically tune the light interference to produce a stable, vivid color that looks the same from almost any angle. Problem solved. So what's the trade-off for all this beautiful, stable color? How much efficiency do we actually lose? Well, the answer is surprisingly little. Depending on the color you choose, the hit to performance is only about 2 to 8%. Honestly, that's a small price to pay to turn our buildings into works of art that also happen to generate clean energy. All right, so from colorful solar facades, let's pivot to another part of the building that's getting a huge upgrade thanks to sputtering: our windows. Now, windows are a whole different ballgame. They have a really tough job. We want them to let all the visible light in, of course, but at the same time, we want them to block heat from coming in on a hot day or escaping on a cold one. So the coating has to be this amazing insulator while also being almost perfectly transparent. It's a tricky balancing act.
And sputtered coatings, well, they totally deliver, creating what we call low E or low emissivity glass. These coatings are just incredible. They drastically reduce heat loss, but keep everything looking crystal clear. They're also super tough, able to handle extreme temperatures. And on top of all that amazing performance, you can still tune their color and reflectivity to get that sleek, modern look.
So what's the secret sauce here? Well, these coatings are what's called metal-dielectric composites. Sputtering is used to lay down these incredibly thin, alternating layers of a metal, like silver, and a non-conducting material like silicon carbide. This tiny nanoscale sandwich is engineered to reflect infrared heat, which is what we feel, while letting visible light pass right through. It's basically a smart filter for sunlight itself. We've seen how sputtering is changing our buildings, but believe me, that's just the tip of the iceberg. This technology is getting ready to make almost any surface you can think of smarter and more beautiful.
Just think about it. We're looking at a future with transparent electronics built right into glass, maybe for the NFC tech that powers tap to pay on your phone. We're going to see even better anti-reflection coatings on our glasses and cameras, and we're going to see advanced coatings that can manage light in completely new ways for things like powerful optical sensors. The possibilities are just blowing up.
And that really brings us full circle, back to our big idea. That central conflict we started with, it's being solved. Technologies like atomic sputtering mean that high performance and beautiful design are no longer enemies. We can engineer materials that are both incredibly efficient and aesthetically brilliant. We get to have our cake and eat it too. So we've basically mastered this art of painting with atoms. We have the power to coat almost any surface with new colors, new functions, new intelligence. And that really just leaves us with one final big question. What are we going to coat next?